Hi everyone. So welcome to INTAREA. We're going to do a quick check here. Yep. Great. So hello, good morning, good evening, good afternoon, wherever you are. This is Juan Carlos Zúñiga and Wasim Haddad. So we're going to start with a few virtual meeting tips and etiquette. So please join the queue before participating. We'll recognize you and give you the word so that we don't overstep each other. Mute your microphone unless you are speaking, and preferably turn off your video. If you are presenting, you can turn it on, but otherwise please turn it off so that we can save bandwidth. Next slide, please. So not well, this is the usual not well. We are holding an official IETF meeting. So you agreed to follow the IETF processes and policies. If you're aware of any contribution covered by patents or patent applications, please let us know. You can send us a message or please disclose it appropriately. Any participant, you agree and acknowledge that it will be, we just lost your screen, Wasim. So you are acknowledged that you are abiding by the IETF processes, BCPs, and you are aware that your contributions are going to be recorded, that minutes are going to be taken, your presence is going to be logged. Wasim, can you share the screen again, please?
To have lost connectivity completely.
Yeah, it looks like he lost connectivity.
All right, so let me try something here. All right, can you guys see my screen?
Yes.
Okay, thank you. So coming back, scribes, please contribute online to the minutes at the code EMD. And Joel, just to confirm, can you help us with the minutes, or was it only scribe for Java?
I'm dealing with scribing because I got other things I got to record. Sorry.
Okay, so we will need someone to help us with the minutes. It could be many people. Can someone help us taking minutes? Please, we need a note taker to be able to hold a meeting.
Notes, Juan Carlos. Not all the time, but I'll be taking some.
Thank you very much.
To help some.
Great, thanks. Was that Pascal? Sorry, I lost the Meetica screen, so. Okay. All right, so Wasim is back, so let me stop sharing and let him share so that I can manage the queue and go back to normal. Okay, so note well, we can go to the next slide. We have note takers, great, and your presence is being logged. So if we can move to the next slide. This is the agenda for today. we're going to have Vlad presenting a small update to the SOX version 6 protocol. Then we're going to have Maxime presenting 3 slides, Pascal with QUIC over PPP, Yihauxia with the 2 flexible IP drafts, and if we have time, we will have Lorenzo presenting the per application networking considerations. Any bashing to the agenda? I see David on the queue.
Hi, can you hear me?
Yes.
So I was genuinely surprised to see items 3, 4, and 5 on the agenda. So as someone who follows kind of both the transport and int areas, these really feel like transport documents, and I feel like both of them were just renamed, or sorry, 2 out of the 3 of them were just renamed from like documents aimed at QUIC. So I would like to ask, like, why are these in INTAREA? Like, they're about like more transport properties than anything else, in my understanding. I guess this is a question for the chairs more than anyone else.
Well, I see Maxime on the queue, so well, he was joining. So if you can take that, Max.
Yeah, of course. Can you hear me?
Yes.
Yes.
Okay, so those 3 documents define an application protocol for QUIC. So as such, I felt they were appropriate for INTAREA, and I contacted the chairs given this. Of course, those documents existed before, so they were as targeted, we could say, to the QUIC working group, but they are not touching on transport properties. They are just an application protocol on top of QUIC.
So if it's just an application protocol, that suggests the application area, not the int area. Oh, I see.
Sorry.
Our AD is coming in.
So it's also touching on internet area, as it's a tunnel. So that's my understanding.
Yeah, that's what I was about to say, David and Maxime. Everything which is tunnel by default is in INTAREA. Now there is MASQUE as well, right? So which is kind of
that's kind of why I'm asking. Yeah.
But it's not yet a working group document, and we need to see what's inside. One potentiality outcome of this presentation today, and thinking over the mailing list, is basically to move this to another working group, right? It's not adopted. This is the first time, so let's see what's inside.
Okay, thanks. I was just genuinely curious, and I'm excited to see the presentations because I mean, as you know, I'm a MASQUE enthusiast, so I'm very much excited about this topic. I was just very surprised to see it here. I almost personally missed it because I wasn't expecting to see it here at all. So yeah, let's maybe continue the discussion in that slot then. Thank you.
Great. So with that, if there's no more agenda bashing, maybe we can move to the next slide. So a quick status update. We had 2 RFCs that have been published, the Discovering Provisioning Domains and Data, RFC 8801, and IP Fragmentation Considered Fragile, 8900. We also have the generic UDP encapsulation, which is on the ISG in AD evaluation status. All right. So since we're a few, Eric, yes, you want to say something?
Yeah, just one thing about this generic UDP encapsulation. So I sent some comment to Tom Herbert and other authors, so they need to revise ID to continue the process. But I don't see Tom here. But yeah, he's aware that he needs to do so few things.
Yes, fair enough. Thank you very much. Yes, we saw your review, and so we're waiting for feedback from the authors. So now, moving on, a small update on the SOX v6. Vlad, are you online? I don't see him online. Okay, so we did get, well, if he's not online, I'm not going to go through the details of this update, but Wasim, can you move to the next slide? Wasim, can you move to the next slide, please? Wasim? Can you go to the last slide of Vlad, please? Yeah, we can see your screen now.
Okay. Can you hear me now?
Yes, we can hear you.
Okay.
Right.
Here you go.
11. Right. So Vlad had made a great. Yeah, small update, and the adoption is still the adoption call is still open. We did see some mild support for this, but we would like to see a little more support. As you recall, this draft has been going on for quite a bit, and Vlad has already presented a few times. He's had positive feedback, and also he's had an implementation that he has already published. So please, if you can, and if you agree, send a message to the list to adopt this draft. We would like to see that. We are also planning to send it to SAG, SEC Dispatch, and MASQUE to let them know that the draft is around and get some more support so that we can adopt it and move it forward. Okay, so since Vlad is not here, let's move any discussion on this to the list, and we can move to the next presentation, I guess.
Yeah.
Thanks. So, Maxime, can you unmute? Yes.
Okay, can you hear me?
Yes.
Yeah.
Okay, thank you. So, yeah, thank you for giving us the opportunity to present our proposal for tunneling internet protocols inside QUIC. So this is joint work with Olivier Bonaventure and Adi Masputra. So Olivier Bonaventure is from UC Louvain, and Adi Masputra is from Apple. Next slide. So our proposal is split in 3 documents, which we will describe separately. So first, we will give an introduction to QUIC so that all participants are kind of on the same page, a short introduction to QUIC. And then we will move on to describing the main document, which is QUIC tunnel, and then 2 optimizations to our proposal. Next slide. So for this introduction to QUIC, I've not taken all the details of QUIC. I've just picked a few relevant items that I think are interesting in the context of creating a tunnel. So QUIC provides services that are equivalent to TCP and TLS, but is built on top UDP. It has a 1RTT authenticate handshake mode by default, but it can also do 0RTT session resumption with some weakened security properties. And one key aspect of QUIC is that all application data is encrypted, and most of the control data is encrypted. And those 2 things give some kind of immunity to most of the middlebox interference, which is a very nice property for transport protocol. It's also likely to pass through many networks as it's being adapted for the web. There are two ways of conveying application data in QUIC. So there is one, which are streams, which are reliable in order either unidirectional or bidirectional byte streams. But there is also more. There is datagrams, which are unreliable message. So it provides services equivalent to TCP and TLS, but also adds this datagram mode. So given those properties, QUIC seems like a good fit for an alternative to IPsec, TLS, or even DTLS tunnels. Next slide. So let's go over our first mode of operation. Next slide. So let's look at the reference environment of our proposal. So we have a client that would like to reach a destination server, and it's connected to one access network, and it will use a concentrator to convey all its traffic over the access network. Next slide. So to do so, the client establishes a quick connection to the concentrator and forwards all its packet to the concentrator. Next slide. Then the concentrator forwards the client packets to the final destination, and it also makes sure that the returning packets reaches the client. Next slide. So let's look now at let's look at a packet sequence diagram to see what's going on to convey those packets at the QUIC level. So first, we have a quick handshake, and we define the QT-LPN to identify our proposal. And so, as indicated by the QUIC specification, the client put this ALPN token to negotiate the application in its first packet to the concentrator, and the concentrator eventually echoes this token to complete the negotiation. So we have a quick handshake, and then once the quick handshake is done, the packets that the client would like to send to the concentrator are put inside datagram frames. So you can see that packet A is put inside the datagram frame, and this packet will be forwarded to the concentrator, will be forwarded by the concentrator to the server. When returning packets arrive to the concentrator, they are put back inside datagram frame and sent to the client. In this mode of operation, we don't provide means of distinguishing the type of packet that is conveyed. So we rely on out-of-band signaling, which makes the proposal very simple. Next slide. There is also another feature of the tunnel mode, which is the ability to report access network availability. So if we take our example, our previous example, in which we send packet A after a quick handshake, now let's say that the client notices that the network is unstable. So when the network is becoming unstable, the client has the ability to signal this to the concentrator using access report TLV, which is a TLV we defined. And so here in our example, the client sends this access report TLV over a QUIC stream, a unidirectional QUIC stream, to indicate that the network is currently unstable. And so the concentrator, given that it has this signal, is free to decide what to do when incoming packets arrive. So we have incoming packet B. At this point, it knows that the network is unstable. It can either buffer the packet or drop the packet, but it knows that it has little value to send the packet over this QUIC tunnel connection. When the network is back again, the client can signal this also, and so it sends this access report TLV with the signal indicating that the network is back. And here in our example, the concentrator has buffered the packet, and it can transmit the packet. Next slide. So that's basically it for the first mode. Should we either stop here for a clarification question, or should we move on to the other modes?
If that's okay, maybe move to the other modes, and then we can take all questions at the end, please.
Okay. Okay, then now we're going to describe the tunnel session mode. Next slide. So the tunnel session mode operates in a similar reference environment, but this time we consider multi-home clients. So a client that is attached to several access network. So it could be a client with Wi-Fi and 5G interfaces, but it could also be a client with an IPv4 and an IPv6 stack. So in this context, the client has access to several networks, as I said, and he would like to leverage those access networks for load sharing or failover, for example. Next slide. So to do so, the client establishes a separate QUIC tunnel connection over each of the access network and use them to send packets to the concentrator that, in the same way as before, will forward them to the final destination. So this is our proposal for the tunnel session, is to use two separate connections. Next slide. But there is also something else that we could do, which is establish an MP QUIC tunnel connection and use the two different subflows, if you like, or path to forward packets to the concentrator. But we prefer to describe the previous solution, which is the two separate QUIC connection, because it's simpler and there is still a lot of work to do on MP QUIC for it to become a reality. So next slide. So let's look at those two separate connections solution. So the tunnel session mode allows to group them in a logical session. So in our example, we can see a green connection A and a B and a blue connection B. So let's say that the client has established the green connection first, and it has access to another access network and established the blue connection later. It can use messages that we defined in the draft to request a new session from the concentrator and associate the blue connection to this very same session. And what this allows is to, it allows the concentrator to do packet reordering across the connections, because it knows that those two QUIC tunnel connections are belonging to the same session. Next slide. So to perform or allow rather the packet reordering, we define a slightly more complex encoding of the packet inside the QUIC datagram frame, which also allows to identify the type of packet that is being conveyed. So here we can identify layer 3 packets or even layer 2 packets as the first 16 bits of this encoding is the protocol type as defined in the other type binary registry. So we can identify any network level packets, but we can also identify an Ethernet frame itself by using transparent Ethernet bridging, for example. So this is the first field of this encoding, and then the second 16-bit field is an opaque value, which can be used for reordering, which we call the packet tag. We will see an example with this on the next slide. Next slide, please. So using those sessions and using this packet tag, the client can, for example, if the client wants to send multiple packets to the concentrator, it can leverage this packet tag to encode the transmission sequence, or, for example, a timestamp, which allows the concentrator to do reordering across the tunnel connection. So here it sends packet A with tag 1, and then packet B with tag 2 on the blue connection, and then packet C with tag 3. Then the concentrator is free to decide the size of the reordering window, how much time it's willing to spend before waiting for a packet to arrive, but it has the tools to perform this reordering, and so it can put back the package in sequence as we can see. Next slide. So this is it for the tunnel session mode. Now we will look at the last mode of operation, which is the stream mode. Next slide. And by now, something that's probably come to your mind is that those two approaches that we've seen have one key advantage, which is to be able to convey many types of protocols, but one drawback, which is the byte overhead it introduces. And in the cases of TCP byte streams, this can be quite high. Next slide. So here we have this TCP packet, actually an IP packet containing a TCP packet that we would like to convey over the tunnel. If we are using the tunnel session mode, we have to add those two fields before the packet. Next slide. Then put it inside the datagram frame. Next slide. And then put this datagram frame inside a QUIC packet. And so if we're dealing with a lot of traffic, this overhead can be significant. Next slide. So what we propose with the stream mode is to change a bit the paradigm on which we operate and to work at the byte stream level and provide a TCP connection to QUIC stream mapping. So let's look at how it works with an example. So here we have the client that sends, so the client that would like to establish TCP connection to the final destination will use messages we've defined in the draft to open a new TCP connection from the concentrator. So it sends this TCP connect TLV on a new stream to the concentrator, and this will get translated by the concentrator to a SYN packet. Next slide. When the SYNAC comes back, the concentrator also does the translation in reverse and sends a message, TCP connect OK, to the client to indicate that the connection has been successfully established. We also provide TLVs for all other means of, so if the connection doesn't succeed, if the connection establishment doesn't succeed, we also provide TLVs for that. So after the connection has been established, the byte stream, the TCP byte stream is simply copied over the QUIC stream. So we can see that the client would like to send some data over the byte stream and sends it in the stream. It gets copied to the TCP connection, and in the same way, returning data from the final destination to the concentrator over this TCP connection gets copied to the QUIC stream. Next slide. In the same way, we also provide translation for closure events. So when the TCP connection closes with a FIN packet, we close one way of the stream, and then when the client would like to close the connection, it closes its own way of the stream, and this gets translated to a FIN packet. Next slide. So this was basically it for the stream mode. And this leads us to the conclusion. So we've seen that QUIC can be used to convey many networks protocol. We think that there is an interest in considering multi-home clients from the start of the work on a tunneling protocol, and to solve this problem, we defined an application protocol to convey internet protocols inside QUIC, and it's split in those 3 documents. There exists already a prototype as part of the PQUIC paper, but we're working on a more fully fledged prototype that we hope to be experimenting with soon, and probably show you some results at some point. Of course, contributions and collaborations are welcome on the GitHub, but maybe let's take a question from the participants first.
Yes, thank you very much, Max. So we have a couple of questions. We have 5 minutes for questions. So, David?
Actually, maybe thinking to wait until the end of the slides for the questions. I just wanted to get in the queue. Or was this the last slide?
Oh, this is the last slide.
This is the last slide.
Oh, okay, great. Sorry, I was looking ahead on the thing, and like you have a next slide in your deck that I find somewhat amusing, and that's what I was going to ask about. This is David Skenazy, MASQUE enthusiast. This sounds a lot like MASQUE, to the point where it pretty much is MASQUE. So take like the entire like especially your stream mode, where you present it as something new. If you look at it from the perspective of an IPsec tunnel, yes, this is new and useful, absolutely. It is useful to have a stream level abstraction instead of a packet level abstraction. I'm totally with you there. Except we already have this. It's called the HTTP3 connect method. It's already completely done. And so I don't understand why there's a new draft that like does a bunch of work to do the same thing. So can you clarify what's the benefit of this over existing systems?
So I have two things to bring. So first, I'm not sure if you were offended by I didn't say new, but that was not my intention.
Oh, no, sorry, I'm not offended.
The draft, okay. The draft QUIC tunnel exists for a long time. It's kind of, it arrived nearly when the first MASQUE proposal arrived also. But yeah, let's look now at the real technical thing. So yeah, the key difference I see is that the MASQUE is defined at H3, you know that, of course. And in our case, we define a simple binary protocol on top of QUIC. And I think the two have advantages.
So what are the advantages of the simple binary protocol? Because I'm not convinced that this is simpler than H3.
Yeah, so it's simple in the sense that you don't need an H3 stack, but of course you will have to implement the protocol. Currently in the document, I find it simple, but of course this is to the appreciation of each one.
But it's it's not an order of magnitude simpler than H3. So yeah, it is simple. I'm not denying that it isn't. But I totally agree. You have a different thing, and if it were just your proposal, it would make sense. But why this proposal when we already have something that works?
So the other thing that I see is the second item on the slide is that we think that there is an interest in considering multi-home clients, and from what I got from the charter, this is currently ruled out from the charter of MASQUE, right? So
from the the MASQUE chairs can well, Eric is in the queue, so I'll defer to him on that point. But when we wrote the charter for MASQUE, the idea was start simple and build up. So, in protocol design in general, you don't want to tackle 17 different problems at the same time, because that makes it almost impossible. So what we decided with MASQUE is we started with Connect UDP. So it allows you to forward UDP packets, just like Connect does for TCP, it does UDP. So it's simple, and that's what we're working on right now. The next thing we're going to do is going to be Connect Network or Connect IP, however you want to call it, a similar thing at the IP layer. And I totally think that once those are done, we could totally bring in multipath to MASQUE if we have clear, use cases and benefits. And I think that's like a natural progression instead of trying to do all the things at the same time, because there's kind of dependencies where, when you change one, you have to redesign the other. And I think, and these ideas of having those multiple paths and maybe making MASQUE path aware, or even QUIC path aware, which is discussions that we're having in the QUIC working group, is useful. I'm not sure that's a good reason to kind of reinvent the entire application layer just because MASQUE doesn't have everything we need today. I think it might be worth it to bring this energy to MASQUE and see how we could fit all of your use cases and needs into MASQUE. And I do realize I'm really sounding like I'm trying to sell MASQUE here, but it's just weird to try to reinvent something when we have something there. So I guess that's my only point. So maybe I hope you can come to MASQUE tomorrow.
Okay, no, I got your point. You were not selling MASQUE. You made reasonable points, of course.
Awesome, thank you.
All right, can I go?
Yeah.
All right. Yeah, so very much echoing what David was saying, I think, just for this group as we are considering it, I think this should absolutely not be done in INTAREA because it's duplicating what is already in the charter of another working group, and we don't want those separate efforts. MASQUE is already building proxying and tunneling over QUIC, and so we should go there, have the conversation there, and there are things that we don't think are correctly in the charter, you can have a rechartering discussion and have the discussion that goes up to the IASG and goes through all of that, but don't just duplicate the work because it doesn't fit into the charter as it is today. As people have mentioned already, the stream mode, it's identical to Connect. When you looked at the draft, it essentially does Connect, but it doesn't do things like being able to connect with a name. So it's like just kind of a lesser version of Connect. And I think these points here about saying that H3 is not too much overhead or it won't support some of these other features, I don't think that's true. And particularly, like recently, I've been working on, for doing MASQUE interop, a very, very minimal version of H3 that you can run that doesn't have to do other things. If you only want to use it for proxying and tunneling, it can be extremely simple. And maybe it would be worth kind of going through the exercise of writing down a minimal guide for how to do that. Maybe that's a draft that's informational. But if you want help kind of figuring out how to make this very thin and lightweight, it is possible. We've already done it.
Okay, thank you.
Okay, thanks. Eric?
Yeah, thank you. So to make a long story short, it looks to me that this proposal that are smart and everything, don't take me wrong, are not really the usual kind of tunnels. So, and it looks like pretty much like a MASQUE thing. So my current thinking is to get a meeting with the INTAREA chairs and the MASQUE chairs, maybe not next week because it's Thanksgiving, and the responsibility for those two groups, and see what we do. But honestly, right now it looks like it's really a MASQUE document and could be used by the MASQUE working group as an input. Again, nice piece of work, but I don't think now that it's the right place to be, INTAREA. And Wasim and GC, and if the people in the queue don't disagree, we may want to stop the queue here just to give time to other drafts. But again, it's up to you and to the people in the queue.
Yes, indeed. I'm looking at the time, and we still have a few presentations. So if you have a point that you want to make very quickly, please go ahead. We're stopping the queue, but if it's a long discussion, we're going to take it to the list. So, Christian, do you have something you want to add?
I pretty much agree with Eric said, and I don't have much to add. Just to say that several of the points, not just the multipass part, but the connecting several quick connections to the same server, it's a much harder problem than what is presented here if you consider server pools. So it's much better to treat that inside MASQUE or inside QUIC than to try to do it on the side. And it's really, I mean, I agree with Eric's points. This belongs in MASQUE, doesn't belong in files.
Thanks. Eric?
I don't want to reiterate everything that was said, although I generally agree with it. I think there was some discussion about this last March on the MASQUE mailing list. And I think the reception was generally that yeah, this kind of thing is something that MASQUE is looking at. So I would encourage you to come there and let's talk. Specifically to the multipath stuff, when we were chartering MASQUE, we basically said MASQUE and the ability to connect and do datagrams and IP and all of that is somewhat orthogonal to whether you're doing that with multipath QUIC or multiple QUIC connections over multiple paths. So I don't think, I think we were not trying to get in front of the discussion happening in the QUIC working group about multipath and all of that. So I don't think we want to turn MASQUE into another place to have that discussion. Let's have the discussion with everybody who needs to be involved. But there's nothing in MASQUE that is anti-multipath, if that makes sense.
Okay, thank you. Vidi?
Can you hear me?
Yes. Yes.
I just have a very quick question about the scheduling on the different paths. So I remember seeing the slide where we were sending packets on from different network interfaces to the concentrator, but I didn't see the response part. So how, is the scheduling described in the draft? Like, how does it decide on which path to send?
So no, we don't take positions on the scheduling, so it's free to the concentrator to the concentrator is free to decide.
Getting echo.
Cool. That was my only question. Thank you.
Thanks. Yella?
This is a question for the chair. I asked this on Jabber. Were the PSV area directors or the MASQUE chairs or the QUIC chairs consulted on these documents? I didn't see an advertisement of this on any of those mailing lists, and so I was a bit surprised to see these pop up here. Anybody want to respond?
Max, do you want to respond to that?
Sorry, I didn't get if the question was directed at me. I'm sorry, could you reiterate the question?
Maxime, it wasn't directed at Maxime, it was directed at the chairs. I'm asking if the transport area directors or the MASQUE chairs or the QUIC chairs, were any of those consulted on these documents being presented here? Of course, you don't need to consult, but it might help if you did consult them to avoid having these sorts of conflicts in the future.
Well, okay, thanks. We take that as an advice. And to answer the question, no, we did not consult them. We looked at the protocol and basically the decision, as Eric said, because it was talking about tunnels, we said, okay, we can hear it, but the decision on adopting or anything would have to be taken afterwards. And right now you've already got the feedback. So no. But thanks for the feedback. Okay,
From
so
the MASQUE perspective, there was some conversation about this kind of use case and stuff, I think, last March, but I haven't seen anything since then, although I'm happy to be wrong there.
Okay, thank you. So we need to move on to the next presentation. So if ever you have any more comments, please send them to the list. Pascal?
Yes, and I'll try to. Okay, can you see me? Can you hear me?
Yeah.
Cool. Okay, so SHAKE is a new RFC 8724 that was designed at the LP1 working group, and Juan Carlos is an active member of that group, and I'm chairing it. So the LP1 working group considers the applicability of SHAKE over a number of low power wide area radios. And we consider the capability to extend the applicability of SHAKE beyond those low power radios, and in particular using PPP as the lingua franca to enable SHAKE over any kind of link. And so we talked with Eric, we kind of went through the possibilities, and we found that LP1 was actually not chartered for looking at SHAKE over PPP. So we kind of decided to move into INTAREA and propose the work at INTAREA. So certainly this work needs two kind of specialties. We need like PPP experts, and we also need SHAKE experts. So certainly it cannot be done fully in either working group, and we really expect collaboration between LP1 and INTAREA. But in terms of charter, the work belongs here. So that's why it's being proposed here. Why do we want SHAKE over PPP? Because if we have PPP, obviously we have zero links, so we can get the traditional RVX links, and we can get 3GPP, etc. We also can benefit from PPP over Ethernet Wi-Fi. So basically we can, through SHAKE over PPP, we can basically deploy SHAKE over anything. So that's why we're so interested in doing it. To enable it, it doesn't take a lot, but we need to to signal a new compression mechanism for PPP. PPP already has two compression mechanisms defined, so it's just like a third one that we look at. And we propose to signal shake as basically a new value for this compression type. And shake requires a data model where you provide the compression rules. It's a completely stateful protocol where every byte kind of maps something in a rule. So we need to provide the rule, and the idea is in this compression header that PPP has, we can actually provide the URL of where the data model is located, because it's very important that both ends of the compression have the exact same vision of this data model. Next slide, please. Okay, so what's new in the draft? First thing is we kind of, to keep things simple, and that's just an attempt, we kind of propose to force the size of what we call the rule ID, which is basically this, the index of the mapping table, which says exactly how you compress this particular packet. We propose to fix it as 2 bytes, so we get everything byte aligned, and it looked like having 14 bits to index the rules for a given flow. That looked like enough. If you want to start another flow, then you can always start another PPP session. Now we'll see later in the slides, but the big question we have is if we force the rule ID size to be aligned, and now we've got all these compression residues, so the result of the shake compression, what's not compressed basically, which could not be bit aligned, then we have a problem with what to do with the padding. So we'll see that in the next slide. Next slide, please. So what we did with this new version is add fragmentation. Initially, there was no fragmentation in shake over PPP because we are saying, hey, PPP applies to links where normally you don't have a frame size limitation. But then we looked at it from a different angle and took requirements from industrial control loops and things like that, where you would like to schedule frames. And if you want to schedule frames, you may want to align them to a very specific size, so it's much easier to schedule. And if you want to do that, then there might be cases for some industrial protocols where whatever size you decide, like 120 bytes or something, does not fit everything. And in that case, you might need to divide the frequency of your updates by 2, but allow 2 fragments or even 3 fragments if you really wanted to. So to be able to maintain this very small frame size, we basically said, oh, then let's use the fragmentation that shake has. Next slide. So the biggest problem we are left is this padding thing. Normally, the way shake would work is that when you're not fully byte aligned, then you put some padding at the end of everything. But here, what we'd like to do is compress maybe most of the beginning of the packet, but then if in this control loop there is kind of a measurement, you would like to leave the measurement uncompressed at the end of the packet. So we would like to be able to signal that up to this point you're compressed, and then after that you're not compressed. And if we look at this, then that means that the padding has to be between the compressed piece and the uncompressed piece. Next slide, please. So that's pretty much where we are and the discussion we want to have. Do we want to maintain the rule of a fixed size and then have to introduce padding between the compressed and uncompressed? Or change slightly the way shake operates? Or maybe find a trick that makes it fit in a generic format. So here I'm giving you how the flow would work. So basically, there are 2 switches or 2 endpoints which operate shake, compression and decompression on the other side. And basically the first thing that needs to happen is to agree on the rule set. That's why we need this URL in the PPP negotiation. And then the URL will be negotiated through the discovery. Next slide, please. So you see this option 2, basically. I'm sorry, back 1 slide. I did not mention one thing. Back 1 slide, please. Yeah, so basically the first thing is the endpoints must locate one another, so there must be a discovery. And then what I mentioned earlier is illustrated here is the IPv6 CP configuration request would have this option too, which says this new compression protocol SHIC and the URL. That's basically what I was saying earlier. Next slide.
Pascal, would you mind skipping this one and going to the questions?
Yeah, this is just for illustration. Let's go to the next. Yeah.
Thanks.
So there we go. Basically calling for adoption, I guess. I mean, like I said, this work has to be done in collaboration with LP1, and for the tiny details of how we do the rules and stuff, that would be done with LP1 support. But from here, we really need to agree on the value of doing SHIC over PPP, and if so, then getting this document adopted. And then I would like feedback on, is it done correctly? Do we need more justification for why we are doing this work, like applicability statement? Is there anything else we would like to mention in this document? So that's basically the open questions.
Okay, thank you very much. So as Pascal mentioned in the beginning, this actually applies a lot to the technology and the work that is being done in the LP1 group, but the applicability brings it to INTAREA. So even though the expertise is mainly there, we want to, if ever this moves forward, want to adopt it here in INTAREA. So if you click on the show of hands bar, we are asking a question. We would like to know how many people have read the draft. So if you can click on the bar chart of the Mitico, and please raise your hand if you have read the draft, or do not raise your hand if you have not read the draft. Okay, so it's still moving. Okay, so we're going to stop it there. We have 419 and 118. So we still don't have that many people reading the draft. Again, this is a draft and a technology that, even though it's been discussed at length in LP1, it'll be nice if you guys can take a look, since this is something we would like to eventually adopt in INTAREA. So please take a look, send your comments, and if possible, answer the questions that Pascal is asking on the mailing list. Okay. So if no more questions, we can move to the next one. Yeah.
Yes, I'm here. Can you hear me?
Yes.
Okay, thanks for the time to present. This proposal is for the flexible IP address address structure for the new scenarios. I'm Yihao Jia from Huawei. Next, please. The first slide is for the gap analysis. The IPv6 has become the core protocol of the entire communication system, and increasingly network scenarios, long form TCP IP for global reachabilities. And as we know, IP address is designed as to hold the only topology semantics only. And here we do see a lot of new scenarios which prefers a flexible IP address, and this is for a new routing capabilities. So we are looking for the new scenarios which could be better to use a flexible IP address structure, and this is for new requirements and can unslash new more possibilities. Next, please. So we should define the flexibility here, and we do post potential orientation here. We see that the feasibility could include multi-semantics, and it could be length variable. And the location for this new scenarios, we see it's called the edge networks. We way to use that new address structure as the limited domain is like in the graph in the right side. The backbone should be the internet IPv6, and the flexible IP should be located at the edge of the network. And the logical position of the flexible IP should be the supplementary of the IPv6 and not replacement. Next, please. The first scenario is the Internet of Things, and as we see, the IPv6 is mentioned for the Internet of Things for the end-to-end reachabilities, and because of its huge address space. And but there is a question here: the energy consumption for IPv6 may be unfollowable for constrained devices. For example, the power requirements, computation requirements. And we do have a solution here. It's called 6LoWPAN. It's feasible, but it's not perfect because they have a lot of action like compression and decompression. So that could introduce extra energy consumption or resource consumptions. And such compression actions may lead to the network delays. So for such scenarios, if we use a flexible address structure, we can use a shorter address, maybe a shorter packet header that could contribute to energy consumption, energy saving, and we can use appropriate gateway to translate from the IPv6 and the flexible IP address structure. Next, please. And
sorry, we have 3 more minutes. You want to take questions here? You want to go through a couple of more slides before?
I'd like to take a question. I will go through all of the name of the scenarios. The second scenario is for satellite networks. We can use geolocation and for low energy consumptions. This is a new scenarios. And the next scenarios, next please, next. It's for the dynamic resources. We can use a flexible structure to encoding identifier, and it's good for us to provide quality of service. And next, please. And we can use flexible structure to encode a new identifier and to identify users or devices, and it's good for the network to directly allow or deny traffic based on the privilege. And next, please. And we can also use a new flexible address structure to embed like the keys, and it's good for authentication, just for like the IPsec. So if we have a flexible IP address, and it could have the integrally keys, and it's good for authentication without key distribution. Next, please. So the main purpose is to propose a flexible IP address, and we propose it to be good enough to accommodate new scenario requirements, and it's just a supplementary of IPv6. Next, please. So that's the last slide here, and it's we want to discuss if it is reasonable for new scenarios to use a flexible IP address structure. Thanks.
Thank you. So we're going to stop the queue at 10. Pascal, please go ahead.
I just want to mention that there was some inexactitude on what was said about 6LoWPAN. So 6LoWPAN enables to forward compressed packets. You can do that with the mesh forms, and with RFC 8138, you can also do that in the route over mode. So you can always forward 6LoWPAN packets, even if they're fragmented, because now you have RFC 8930 and 8931, which enable to forward fragments as well. So the point that you could not forward 6LoWPAN compressed packet is not exact. Yeah, so that's a major thing. Now, 6LoWPAN is not a flexible address structure. It is a compression, right? So you can always come back to normal IPv6. So it does not really compare, but the argument against 6LoWPAN here is not exact.
Okay.
Thank you. Thank you. I do see this flexible structure as a parallel solutions, and 6LoWPAN works, and maybe a flexible address structure may still works for the IoT scenarios.
Thanks. Ron?
I realize that you have some use cases that require additional information in IPv6 headers. You've proposed encoding it in an IPv6 address and even making variable length IPv6 addresses. The problem is, once you make an IPv6 address variable length, it's no longer IPv6, it's something else. So I'd recommend that you think about encoding this extra information someplace other than the destination address. Maybe use extension headers. If that doesn't work at all, maybe what you're working on is something that is not IPv6. As much as I hate to say it, you might be talking about IPv10 or something like that.
Mm-hmm.
But the minute you make a IPv6 address variable length, it's no longer IPv6.
Yes, yes. It's not exactly IPv6, or it's not similar. We just use the address, the definition of the address, but we hope that the structure could not be fixed like 168 bytes, and it could be flexible, and it could contain more semantics and length variable. So it's different from the IPv6, but it still could be compatible with the IPv6.
Okay.
Thanks. So if ever there's more feedback, let's take it to the list. Ted, you're on.
Thanks very much for your presentation and for ending with such a clear question. Are these scenarios reasonable for a flexible address structure? And I think the answer is basically no. And I think it's no for three kind of reasons. One, programmatic, one architectural, and one sort of from a policy basis. The programmatic one is you're trying to do a whole bunch of different things, and you picked one particular tool and said, I'm going to use this tool to do all of these different things. And the result of that is you're going to end up, one, making the tool less optimal for its original usage. Two, all of the different things you're trying to do are going to be at cross purposes as you're trying to fit them into the new structures within the existing tool. And the result of it is exactly the architectural problem that occurs, and that you note in your slide, that you're going to have to gateway. And those gateways will not actually be part of the internet. Those will be networks which connect to the internet through a gateway, because you will not be able to pass from the gatewayed portion through the rest of the internet if there is no gateway on path that's capable of understanding the distinctions you're trying to make within it. So I think that this is not only not a great idea from the point of view of an addressing architecture, it's actually a terrible idea from the point of view of keeping the internet a single unitary internetworking layer. So I think it's kind of problematic from that architectural perspective. Lastly, some of what you want to do is actually contrary to the policy that the IETF has set out for encouraging further privacy in the network, particularly encoding user identifiers into an address space so that they must be carried through the network is sort of inimical to the work that's been done in the security area and by the IAB to foster more security in the network. So I think the best thing to do here is really to pick one of these use cases. You've got the satellite use case, see if there are use cases that you can take one and figure out the best tool for that. Because there may be some of these that if you pull them into the Lego bricks, you can generate something useful from them. But trying to build all of this with a single tool is I think both going to be very difficult and the wrong idea. Thank you very much for your time again.
Thank you. Thank you for comments. I guess that scenario is just located as a limited domain and the age of the network, so it could be experimental. So we try to just develop the prototype for the age network and for small scenarios, more networks to make it to see if it works or not. We hope it could be start from the experiment.
Okay, so thank you very much. We'll have to stop the meeting here. Unfortunately, we didn't have time to go through the last set of presentations, but please continue the discussion on the list. Thanks everyone for your patience and cooperation with these meetings.
Thank you.
Thanks. So goodbye, everyone.
Thank you.